Hey guys, so in this video we're going to look at the graphs of the trigonometric functions. And we're going to start by looking at the unit circle. So here we have the unit circle that has center point at the origin and it has radius 1 unit. And first we're going to look at the graph for y is equal to cosine of x. Here x is the angle theta subtended from the positive x-axis. We also know that the cosine of theta is the x-coordinate of the point on the unit circle when an angle theta is subtended. So here when the angle x subtended from the positive x-axis is 0 radians or 0 degrees, the point on the unit circle has x coordinate 1. So when the angle x is 0 radians or 0 degrees, we know that the cosine of x is simply 1. That's the x coordinate here. So when x is equal to 0 radians here, we have the angle on the x-axis. So when x is 0 radians or 0 degrees, the cosine of x is equal to 1. Now when the angle x is pi over 2 radians or 90 degrees, the angle is pi over 2 radians or 90 degrees, the x coordinate of the point on the unit circle is 0. That means the cosine of x is 0. So when x is 90 degrees or pi over 2 radians, here x is shown in radians again, when x is equal to pi over 2 radians, cosine of x is equal to 0. When x is equal to pi radians or 180 degrees, the x coordinate is negative 1. So when the angle is pi radians or 180 degrees, cosine of x is equal to negative 1. When x is equal to 3 pi over 2 radians or 270 degrees, again the x coordinate is equal to 0. So cosine of x is equal to 0 when the angle is 3 pi over 2 radians or 270 degrees. And then after 2 pi radians or 360 degrees, we complete a full revolution. And again, we can see that the x coordinate is 1 again. So we know when the angle x is equal to 2 pi radians or 360 degrees, cosine of x is equal to 1. Now here, of course, the angle x was subtended counterclockwise from the positive x-axis. So x was positive, the angle x was positive. However, we can also see what happens to the graph when the angle x is negative. So here we're going to subtend the angle x clockwise from the positive x-axis. So when x is equal to minus 90 degrees or minus pi over 2 radians, the x coordinate of the point on the unit circle is simply 0. So when the angle x is negative pi over 2 radians or negative 90 degrees, cosine of x is equal to 0. Similarly, when the angle x is negative pi radians or negative 180 degrees, then we can see that the x coordinate is negative 1. So therefore, when x is equal to negative pi radians or negative 180 degrees, cosine of x is equal to negative 1. When the angle x is negative 3 pi over 2 radians or negative 270 degrees, the x coordinate of the point on the unit circle is 0. So when x is negative 3 pi over 2 radians or negative 270 degrees, cosine of x again is equal to 0. And when x is equal to negative 2 pi radians, now again we've completed a full revolution. The x coordinate of the point of the unit circle is simply 1. So when the angle x is negative 2 pi radians or negative 360 degrees, we can see that cosine of x is equal to 1. Now what we can see over here is when we look at the graph for y is equal to cosine of x, again where x is the angle, it could be in radians as I've shown or it could be in degrees, we can see that the curve shows a repetitive pattern. So what we see here is from negative 2 pi to 0, the curve looks identical to what it looks like from 0 to 2 pi. And if we increase the angle from 2 pi and beyond, we see that this pattern is going to repeat itself. This pattern that we see here is going to repeat itself. So we can see that the curve for y is equal to cosine of x completes one full cycle in 2 pi radians or 360 degrees. We can see this cycle complete itself in 360 degrees. Every 360 degrees, we see this curve repeating itself. So we can say that the period for this curve is 2 pi radians or 360 degrees. What that means is that the curve shows a repetitive pattern every 2 pi radians or 360 degrees. Another thing we notice over here is that the maximum value for cosine of x, the maximum value is 1 and the minimum value is negative 1. So cosine of x ranges from 1 to negative 1. So that is the range for the function cosine of x. Next, we're going to look at the graph for y is equal to sine x. Now we know for an angle theta subtended from the positive x-axis, sine theta is the y coordinate of the point on the unit circle. So when theta is equal to 0 degrees or 0 radians, that is x, the angle x is equal to 0 degrees or 0 radians, we know that the y coordinate is simply 0. So when x is equal to 0 radians or 0 degrees, sine of x is equal to 0. When x is equal to pi over 2 radians or 90 degrees, so when the angle is pi over 2 radians or 90 degrees, we can see that the y coordinate is 1. So when x is pi over 2 radians, sine of x is 1. When the angle x is pi radians or 180 degrees, the y coordinate again is equal to 0. So when the angle x over here is pi radians or 180 degrees, sine of x, that's the y coordinate on this graph, is equal to 0. When the angle x over here is 3 pi over 2 radians or 270 degrees, the y coordinate on the unit circle is negative 1. So we know that when the angle x is 3 pi over 2 radians or 270 degrees, sine x is equal to negative 1. And then when the angle is 2 pi radians or 360 degrees, we've completed a full revolution. And we know that the y coordinate of the point on the circle is 0. So sine x is equal to 0 when the angle x is equal to 2 pi radians or 360 degrees. And here again, we were looking at values of sine x when the angle x is positive, that is, it's subtended counterclockwise from the positive x-axis. If the angle is negative, if it's subtended clockwise from the positive x-axis, again, we start at 0 degrees or 0 radians. The y coordinate is equal to 0. So we start at 0. When the angle x is negative pi over 2 radians or negative 90 degrees, the y coordinate is negative 1. When the angle is negative pi radians or negative 180 degrees, again the y coordinate is 0. So when x is negative pi radians or negative 180 degrees, sine of x is 0. When the angle is negative 3 pi over 2 radians, that is negative 270 degrees, the y coordinate is equal to 1. So again, when x is equal to negative 3 pi over 2 radians or negative 270 degrees, sine x is equal to 1. And at negative 2 pi radians or negative 360 degrees, we again complete a full revolution and the y coordinate is equal to 0. So when the angle x is negative 2 pi radians or negative 360 degrees, we can see that sine x is equal to 0. Now again, if we look at the graph for y is equal to sine x, we can see a repeating pattern. We can see this wave-like pattern repeating itself every 2 pi radians or every 360 degrees. I've highlighted this pattern over here, so we can see that this pattern of the wave, or this wave repeats itself every 2 pi radians. From 0 to 2 pi, it looks identical to what it does from negative 2 pi to 0. So we can say again that this wave has a period of 360 degrees or 2 pi radians. So we can say that the sine wave has a period of 2 pi radians or 360 degrees. And again, we can see that the function sine x ranges from negative 1, that's the minimum value, to positive 1. So we can say that the range of sine x is lesser than or equal to 1 and greater than or equal to negative 1. It covers all values between negative 1 and 1. That is a range of outputs for the function f of x is equal to sine x. Next, we're going to look at the graph for y is equal to tan of x. Now, we may remember that tan of x or tan of theta is simply the ratio between the y and x coordinates on the unit circle. Or we can say that it is the sine of theta divided by the cosine of theta. So now if we look at the unit circle, we can see that when theta is equal to 0 degrees, or the angle x is equal to 0 radians or 0 degrees, the y coordinate, that is sine of x, is 0, and the x coordinate, that is the cosine of x, is equal to 1. So sine of x divided by cosine of x, that is 0 divided by 1, that is tan of x, and that is equal to 0. So when the angle x is 0 radians or 0 degrees, tan of x is 0. Now when the angle x is 45 degrees or pi over 4 radians, we can see that the x and the y coordinates are the same. So y divided by x, that is sine x over cosine of x, is equal to 1. So we can see here that when x is pi over 4 radians or 45 degrees, tan of x is equal to 1. Now if we see as the angle x increases further and further, what we can see is that when x is equal to 90 degrees, when the angle is 90 degrees or pi over 2 radians, we can see that the y coordinate is 1 and the x coordinate is 0 on the unit circle, and 1 divided by 0 is undefined. But what's happening here is that as the angle is getting closer and closer to 90 degrees or pi over 2 radians, the ratio between y and x is increasing. The y coordinate keeps on increasing and the x coordinate keeps on decreasing. However, at pi over 2 radians or 90 degrees, tan of x is undefined. So when the angle x is 90 degrees or pi over 2 radians, tan of x is undefined. But it gets larger and larger and larger and approaches an infinitely large value as the angle x approaches 90 degrees or pi over 2 radians. If we go past pi over 2 radians, again it's an infinitely large value just past pi over 2 radians, but now it's negative, since on the left hand side of the y-axis the x coordinate would be negative. So it's a very, very large negative value, and then it decreases in magnitude. At 3 pi over 4 radians, we have the x coordinate is negative root 2 over 2 and the y coordinate is root 2 over 2. So tan of x is simply y over x, so that will be negative 1. So when the angle x is 3 pi over 4 radians or 135 degrees, tan of x is equal to negative 1. And when the angle x is pi radians or 180 degrees, The y coordinate is 0 and the x coordinate is -1. So 0 divided by -1 gives us 0. So when x is equal to pi radians or 180 degrees, tan of x is equal to 0. Now at 5 pi over 4 radians, tan of x is again 1. That's -√2/2 divided by -√2/2. So at 5 pi over 4 radians, that is 225 degrees. Tan x is equal to 1. Now again, when x is equal to 3 pi over 2 radians, we can see over here that the y coordinate is -1 and the x coordinate is 0. And -1 divided by 0 is undefined. That's y divided by x. However, if we look at the angle x as it approaches 3 pi over 2, we can see that the x coordinate is still negative and the y coordinate is also negative. But the y coordinate is getting closer and closer to -1, whereas the x coordinate is getting closer and closer to 0. Since they're both negative, their ratio must be positive. But since x is getting closer and closer to 0, again, it's approaching an infinitely large value as x approaches 3 pi over 2 radians, and it's undefined at 3 pi over 2 radians. Now again, if you look past 3 pi over 2 radians, what we see here is that now the x coordinate is positive, right? We're on the right hand side of the y-axis, but the y coordinate is still negative. And what we see is that the y coordinate becomes less and less negative, and the x coordinate becomes greater in magnitude. So what we have is we have a negative value divided by a positive value. So we know that tan of x is negative between 3 pi over 2 and 2 pi radians. However, it's infinitely negative. It's a very, very, very large negative value if it's very, very close to the y-axis, and it becomes less negative. At 7 pi over 4 radians, it's equal to -1. Again, that's the ratio of y over x. At 7 pi over 4, it's equal to -1. And then at 2 pi radians, we've completed a full cycle where tan of x is equal to 0 again. When x is equal to 0 radians or 0 degrees, tan of x is simply 0. When it's equal to -45 degrees or negative pi over 4 radians, it's equal to -1. When it's a -90 degrees or negative pi over 2 radians, it's undefined. But just before that, it's a very, very large negative value. At -3 pi over 4 radians or -135 degrees, tan of x is equal to 1 again. So that's over here. Tan of x is equal to 1 when x is equal to -3 pi over 4 radians. And then negative pi radians is equal to 0. That's 0 divided by -1. And -5 pi over 4 radians, again, we're going to take the y coordinate divided by the x coordinate. So that is equal to -1 and -5 pi over 4 radians. And again, it's going to get increasingly negative, and it's going to get to an increasingly large negative value or an infinitely large negative value as the angle gets closer and closer to -3 pi over 2 radians. And just past that point, it's an infinitely large positive value. And then it gets less and less positive, and -7 pi over 4 radians, again y over x is equal to 1, so tan x is equal to 1, and then at -2 pi radians or -360 degrees, tan x is equal to 0 again. Now one thing to note over here is that the period of the tan wave is 180 degrees. We can see this pattern repeat itself every 180 degrees. So here I've shown the interval from -3 pi over 2 to -pi over 2. That is from -270 to -90 degrees. That's a 180 degree interval. Again, we can see the same pattern repeat itself for the next 180 degrees and the next 180 degrees and so on. Or if we start at 0, over here, we can see this pattern repeating itself. We see this and this, right? And we can see again this pattern repeats itself. So over here, the tan wave actually has a period of 180 degrees. So the period for tan of x is 180 degrees or pi radians. And the range for the function tan of x, is unbounded. Since we can clearly see over here that it approaches an infinitely large value here and an infinitely negative value over here. Infinitely large positive value and infinitely large negative value. So tan x does not have a finite range.